Okay, so let's get started. Hi and welcome to our talk, Ruby is Magic. I'm Sebastian and this is Dirk, and Ruby is Magic is actually a series of presentations we are doing at the local Ruby user group here in Cologne, and normally in German. But we were forced to do it in English, and okay. What we do in the presentations in the user group is presenting curious, weird, crazy, interesting stuff about Ruby and the ecosystem we are living in and working in. And we would like to bring some of those to you today. And whether you do Ruby or not, maybe you can learn something or take something back from the concepts we are showing to you, to your work. And we would like to start with a bit of the philosophy behind Ruby. And to do that, we asked, or we didn't ask, but someone asked Mats, the creator of Ruby, what he thinks makes a good programming language. And he said that it should help human thoughts or support you by thinking about what you do. And as you reminded me today, that it's also not about that you, while you're writing code, you should be supported, but when someone else later reads your code, it should help him to, the language should help him to what you expressed previously. In general, it should help you to think better about your problem, and in the end, obviously, it should make you a better programmer. A good language should make you a better programmer. And some more stuff that Mats says regularly on several occasions is that Ruby is about making programmers happy, and that he wants to minimize frustration during programming, and and he often says that the human factor in software development should not be underestimated. So he designed Ruby to be for programmer productivity and fun. And what's very interesting, in my opinion, or in our opinion, is that he compares designing a language to, or a programming language to the principles behind it with the principles of good with good user interface design. So he says that the programming language is sort of a user interface for the programmer as the user to interact with the computer. And the last thing here, and I think it's often misquoted as that Ruby is follows the principle of least surprise. Yeah. Was it surprise? Yeah, right. But actually, it's more like a principle of least astonishment, so that the confusion for an experienced user is minimized. And das machst du weiter, oder? Yeah, okay, then I'll give back to Dirk.
Okay, so after we heard something about the philosophy behind the language, we want to present you some of the essential or core concepts of the language itself. And we start with maybe the one thing that defines Ruby, and what you will read all over again when you try to learn Ruby, or even if you're an experienced developer. That's all over the place. Everything in Ruby is an object. And we wanted to illustrate this with those things that in other languages normally are not objects, like nil. You can ask nil, what's your class? And it says it's nil class. You can ask true to give your its class, its true class, and false is obviously false class. But there's no Boolean class in Ruby. And you can ask some integer or fixed num, how it's called in Ruby, about its class, and you get the class as well. And when I say everything in Ruby is an object, that's true, but there are some minor exceptions, like keywords or argument lists you pass into methods. They're not objects in the language itself. And yeah, something I read about it, what I found really good to express this is you can see them as a framework for your objects to live in. So if begin, those keywords down in the language are to provide some framework so you can program. But without any exception, everything in Ruby evaluates to an object. So whatever you write, you will always get back an object. And at least you will get the nil object. And something very close to this one is everything in Ruby is a method. Again, almost. Those Boolean operators like and, or are not methods, but almost everything else. Even those what you normally expect to be operators, like these arithmetic operators, this minus operation is just a method on the fixnum class. So we presented, wanted to make it clear by doing a fake implementation, obviously, because the real implementation wouldn't be like this, because it's down in C-land somewhere. But nevertheless, it's a method, and this would actually work if it wouldn't be already there. But whatever. And something that's corresponding to this, of course, methods are objects again. So you can ask every object about some of its methods, and you will get a method object back, what you can pass around and interact with, whatever you like. Yeah, some other very basic or fundamental concept in Ruby is the concept of open class. That's something you will stumble across all the time when you're doing Ruby. What's behind this is, when you define a class, you can always reopen it by just write it again. It will not be overwritten. It will just append to the existing class functionality. So we are able to do something like this and define the method days and ago on fixnum to write something like 10 days or 2 days dot ago. Yeah, and that's mainly to improve readability when you're interacting. Yeah, 10 days is much more readable than this this number that evaluates to this 864,000. Yeah, and 2 days ago is even more expressive than just doing the arithmetics in the code. And you don't have to do this by subclassing from any other class or something else. You just can reopen it, and this can be done during runtime as well, but that we will see later. One word of warning at this point. Of course, this can be bad as well, and it's also known as monkey patching. Yeah, it's done in a lot of places, a lot of frameworks doing it. So maybe the bigger ones, Rails for example, is doing this really a lot with its active support sub-framework. So or it's all over the place, those days and ago methods or something similar. Yeah, when you're doing this, of course, you have to be careful not to overwriting some other functionality. So maybe keep it in namespaces or something like this. But if done wisely, it can really improve your readability. Another core feature of Ruby, which comes handy, yeah, maybe all the times, are closures. Closures are so for everybody who doesn't know it, or even if you know it, it's always good to give a short definition for those things. Closures are blocks of code which you can pass around, assign to variables, store for later usage or something. They can be called anytime by anyone, as far as anyone has access to it in its current scope, of course. And it catches the variables where you defined it originally. Yeah, and when you, sorry? Yeah, and of course, closures are objects, which is clear by the next or the last point on this slide, because all closures, there are a lot of them in Ruby, can be called by the call method. So whenever you got an object, you can send it the call method, pass in some arguments, whatever, and the closure will be executed. Okay, to give you some short example of this, maybe the most commonly used example for closures, the usage of closures in Ruby are iterators. You will hardly find any for loops or something like this. And even if you're using a for loop in Ruby, which is syntactically possible, it will boil down to an iterator. So it's just syntactic sugar, the for loop. Yeah, what's happening here? We're defining an array, so a list of three items of different classes: fixed num, string, and float. And the each method is the iterator in the end, and we are passing in a block of code, our closure, to print each item to standard out. One thing you will meet when you're doing Ruby is duck typing. Maybe for me it was present right at the beginning when I started to learn Ruby. One of the first things you see is this duck typing thing. So, and again, we forgot to mention Ruby is a dynamic programming language which is interpreted, and duck typing plays nicely with this. Because in Ruby you're relying less on the specific type of objects, but more on what these objects are capable of. So instead of asking, are you a string? Yes, you are a string, so I can do string stuff with you. I just expect some methods I can do with strings. So, and if it's not a string, I don't care. I just do this methods and hope they are implemented as I expected. Yeah, and one quote you always hear is, if it's talk like a duck and walk like a duck, maybe it's a duck, and you just stop caring. One example from daily usage could be for this to have different database connectors for, in this case, you got some for your production code, which actually writes to the database and stores data in it, and one for your tests or dev environment where maybe you want to use an in-memory database or some other kind of a database, or even just a fake database to improve the performance of your unit tests. You don't have to inherit from any kind of class for this. You just define those methods. You pass in your fake database in your test and just call save. No other checks needed. Yeah, that's, I think, is a really good example for duck typing and minimizing the noise in your code without expecting or checking on specific types. Yeah, and the dynamic nature of Ruby brings dynamic runtime environment, and there you can do really a lot, and that's almost all the time. The magic in our talks is about this dynamic stuff you can do during Ruby execution, and some of them we will show you later. Among those things you can do is you can change almost everything during runtime. Classes can be changed, you can add classes, you can remove methods, you can rename methods, you can add instance variables, whatever you like. Another thing is you have really great introspection capabilities. You can ask about almost everything, every object. You can ask the environment itself about how many objects there are. You can ask, of course, what type are you, what methods do you respond to, and the like. And what's really handy is there are a lot of notifications you can register with callback methods, which happen for events like a new class is created, a class is inherited, a method had been added to some class, or a method is missing from. So if you want to call a method and it's not there, one of those callbacks is triggered. And and these are some examples of this introspection and callback capabilities. So what you find usually is respond to. If you want to make sure you don't get no method error, you can ask beforehand, do you respond to this method I want to send you? And this, of course, would only be true if you applied our monkey patch from earlier. And the method missing will be triggered by the Ruby interpreter every time it doesn't know how to respond to a method you send the object. And you will get past the name of that method you try to call and its arguments. And yeah, what we are doing here, just creating a new instance, calling blah, and it will print out what's inside this method. If you're not implementing the method, there's still a message somewhere down the Ruby core, which will get called, and it will raise a no method error, obviously. Okay, that's so the basic stuff. And now to some more magical parts, and Sebastian will continue.
Yeah, now we are going to apply some of the magic we've seen before to a few example areas. One is domain-specific languages, which is really nice and easy to do or to implement in Ruby, and this it's pretty nice if you remember what Mats says about the user interface principles, and basically domain-specific language is an even more specific user interface that's customly built for your needs. We have a couple of examples here. This is a complete Sinatra application, which is a micro web framework thing. I don't know how to put it better. And what you do here is you say, okay, if there is a GET request coming in at this path, and there's a dynamic type in the path, then run the block and do a print out or respond with hello and the parameter. And and this is already using some of the core principles, like having a block of code, a closure that's executed in a different context, in the context of the request. Another pretty common example would be Active Record, the ORM layer of Rails, or at least the default one, where you have tons of domain-specific methods you can do. They almost look like keywords, and some editors even highlight them as keywords because they are so commonly used. For example, you can specify relations within one line, like a customer has many orders, and the order should be destroyed if the customer gets destroyed. Or you want to validate the presence of a field, for example, and there are endless more like those. This is an example from RSpec, one of the, I would say, more popular testing frameworks. Testing is very deeply into the Ruby culture and community, and RSpec is a behavior-driven test framework. At least they say so. And you have a specific DSL to describe your desired behavior of an account, for example, and you can almost write in a natural language what you expect the account to behave like when it's newly created. For example, the balance should be 0, and you have those nice, you have this nice framework in form of the DSL to write your tests. This is not so known example. No, it's we just made it up. DSLs are often used for configuration stuff, and we chose this because we can easily show you how to do it later. You simply say, okay, I want my this could live in a file. Could be one file per environment, for example, and you do different kinds of things when you load, for example, the development version or the production version, and you can just write down what you want to do and configure it. And the advantage here, for example, is over using JSON or something, or XML, whatever, is that you can use normal Ruby code and all the extended things we showed you before to make it more readable. Like you want a timeout of 2 minutes and a buffer size of something 500 kilobytes, for example. And there are a couple of techniques you apply in order to build a DSL in Ruby, and I think we already talked about all of them. We we saw blocks of code and closures everywhere. All these do ends are code blocks, and often you rely on executing the code block multiple times in different contexts, like for the Sinatra example, where the block is called in the context of the request multiple times. What you also often see is the extension of the Ruby core objects or standard library to make it more readable and so on. And the most important part is of course metaprogramming, which is enabled, like Dirk said, from the great introspection capabilities and the great power you have to change your environment while you're running. And what you use for DSLs often is you generate code dynamically, or is it code or methods? We have an example later. And and the method missing callback, for example, is also quite often used. And to quickly show you how you can or could implement this configuration thing is, this is basically everything. Here we simply define a class method configure on our application so that we can call application.configure. We take a block, we create a new instance with new, and then we just evaluate the block in the context of our new instance. This is the first part, and then we don't implement anything else but the method missing. We simply accept all messages we are getting, and we are creating an internal data structure to save under the method the argument we are getting. And this is creating a hash, but you could do whatever you like in this place. And this is all you need to do in order to implement a DSL in this case. You could also extend the method missing call a bit. You can ask if there are any arguments at all. If there are arguments, then you assign something, and if there are no arguments, you are returning the value if you want to use the same semantics to get data back or configuration back out. Always nice if you can read your configuration. Another approach would be that you specify all the configuration options you have and don't rely on method missing in order to set them, but you simply create a method dynamically for all your configured options, and then you do the assignment within your generated method. Another example with Dirk.
Okay, and this one is, we did this 2 years ago, and I think we think it's still a great example of how powerful Ruby is and what you can do with really a small amount of code and to enhance your code. And decorators is about this example. So imagine you got the DB layer, whatever, who's accessing the database, and you're going to find method on it to find some record by ID, and obviously you want to do some caching. And you could implement the caching inside the find method, or you could use some other Ruby facilities like alias method stuff or so, but that's got really ugly because defining caching inside this find method, it's not really concerned with caching, it's concerned with getting stuff out of the database. And so we decided it would be nice to write above the method a decorate keyword. It's again a DSL, nothing less. And say we want to decorate this method with a cache decorator. And anyone who's familiar with Python, that's nearly the same syntax as Python is capable from the start. So we just wanted to re-implement this in Ruby. So the cache decorator, he's inheriting from some base decorator, ignores this for now. There's happening some other stuff, but the fundamental thing, which is interesting at this point, there's a call method that has nothing to do with a call method from closures. We just named it call because it makes sense to name it call. And And the closure.call, the closure is a method find from the database object. And we're going to call that closure with a call method. Pass in the arguments, which should be the ID for this method. We're getting back the result, and yeah, we are doing some caching because now we're just doing nothing and returning it. Pretty useless. But you could imagine to set up the cache or check if it's already still valid to get it from the cache or whatever, and then we are returning the result. Okay, that would be great. How do we do it? There are 4 points we have to do in order to get to this result. First, we have to detect if a method is decorated or should be decorated by any decorator. Then we have to extract that method from the original class, initialize the decorator with this method. So we got this add closure we saw earlier. And then we have to define a proxy method on the original object, the database layer class, which will later call the decorator, which then will call the original method. And the first thing is detection. We got this method added callback, so this will call every time a new method is added to a class. And yeah, for our instance, this will be called with the find symbol or a string find as a name parameter. And then we gonna check is there a decorator, should be the decorator defined, and if that's true, we're gonna call this decorator helper, which I'll show you next. And all the code on the next slides will happen in this apply decorator method. And we're going to pass in the decorator class. This will be the cache decorator in our case. The name of the method, which should be find in this case, and self, which will be the database layer class. Inside this apply decorator method, we're first going to extract the method from the database layer. This can we do by asking it from to get the method with instant method, because it's an instant method. It's like the one we saw earlier on the minus method on fixnum. It's just more specific to use instance at this point. We pass in the name, we get the method, and then we're going to remove this method from the database layer. After this line, the database layer will no longer be able to respond to the find method. And then we're going to instantiate the decorator class, pass in the original find method, and store it into some internal hash, in this case, to reference to it later. And after this, we're going to define the proxy method, and this is just inline, just a string sorry, of Ruby code. We're going to evaluate inside the DB layer class. It's the class eval. So we're just passing in a new method, which will call, which will look up the decorator inside our internal structure and call the call method from the cache decorator, pass in all the parameters it got, yeah, and you will receive the result from the cache decorator. I hope this was something near clear. Any questions, you can ask us later. Yeah, and that's our short journey through Ruby. I got one more thing for you. So tomorrow, first we're gonna watch this video. So we mention we do always this pony stuff at Colonna B. Not everybody's happy with it. Tomorrow at SIGINT there will be a kids workshop. So any of you who has kids, or maybe some are here who want to come. Yeah, we want to try to bring programming with Ruby, obviously, near your kids. So yeah, it's starting at 12. It's running till 6 in the afternoon. Yeah, maybe we will see some of you again. And that's it. I think we have time for some questions. No questions? Okay. Yeah, thank you for listening, and enjoy the conference.